Hello everyone. 3 months ago, I uploaded a video which showed how to use multiple PZEM devices with an ESP32 to monitor different power circuits. I have used that to build a power monitoring system for my whole house. And in this video, I'll show you how that works. This video will just be a demonstration and with very little technical information. All of that, for example, my ESP home configurations and my home assistant automations will be in a GitHub repository that I'll link below in the video description. Right now, I'm in a shed outside my house where all the power related stuff is present. For example, I get the grid supply here, which goes into this servo stabilizer. This gives me a stabilized voltage of around 230 volts, which I use inside my house. I also have installed a diesel generator here, which I use in case of emergencies. We have frequent power cuts here, and for most of them I use my inverter that I have installed inside. But in case the power cut is very long, say for example 6 to 7 hours, then I need to use this diesel generator to keep the electricity on inside my house. So to monitor all of this, I have made this power monitoring box. You will see that I have installed some 7-segment displays here as well. This gives me all the information about the power data inside this shed. So for example, the first one is the grid voltage and power. So whatever is the voltage of the grid supply and whatever power I am consuming right now. The next is the servo voltage and power. So you might think that the power that I'm consuming on the servo circuit is almost the same as the one I'm consuming on the grid circuit, which is kind of true. But I wanted to monitor this because around a year ago I had a different servo stabilizer, which was a smaller one installed inside my house. It developed some sort of a fault and we knew about it immediately because there was a very bad smell associated with it. But this one, since it's installed outside the house, we won't know it from the smell alone. When the fault happened, the older servo had a really big spike in the power consumption. So that's why I've installed power monitoring here. So in case there's some sort of a fault and the power consumption of the servo increases from the general 30 to 40 watts, I'll be notified about it. Next, we have the generator voltage and power, which is turned off right now because the generator is not working. There are some special things that I've done here. So for example, since this was outside the house, I wasn't sure what kind of Wi-Fi reception I'll get here. So I did not want to risk it and I used a Cat6 cable with a special ESP32 board that has an Ethernet port. So the ESP32 is connected to my network using Ethernet. So it's very reliable. Also, when this place was being constructed, I asked the electrician to give me separate sockets for each circuit. So when I installed this power monitoring box, it became very easy for me. For example, I have the direct supply here from the grid, the servo supply, the generator supply, which is turned off right now, and one plug for the inverter connection. This is what I'm using to power all of this. So in case a power cut happens, this does not turn off and I can still get the power data. Also, you will know that the PZEM come with some clamps to monitor the power consumption. I've installed those here and in the box here. Those clamps have some wires that are very small and you need to extend them when you are doing some practical installation. So for that, I have used some Cat6 cables. Two of the clamps are connected to one Cat6 cable and the other one is connected to a different Cat6 cables. Technically, you can connect up to 4 clamps on the Cat6 cables because there are 8 pairs of wires inside there. But to my situation, I had to use 2 different ones because the installation location was slightly different. I'll try and get some B-roll shots if I can of the installation so that you can see how it looks like. To make the box, what I did was I purchased a project box from Amazon. I cut the lid using some cutter that I had and I 3D printed this plate with all the labels and everything and installed the displays on this plate. Then glued this plate to the lid of the box. That's how I made this. Inside my house, I have also installed 3 PZEMs to an ESP32. It's not fancy like this one, but does its job pretty well. Like I said, I have an inverter installed inside the house. I use 2 PZEMs to monitor the input and output of it. It helps me to judge how much power is being consumed from the inverter, how much charge it is getting, and based on all of that data, I'm able to figure out what the capacity of the inverter is and how much runtime I have left. The third PZEM inside the house is used to monitor some other circuit that I have. Next, I'll show you the home assistant dashboard that I've made and all the automations that I've created using all of these devices. Okay, now that I've shown you what my hardware looks like, I'll show you what my dashboard looks like and what kind of automations I have set up. So as you'll see, this section here uses all the PZEMs that I've deployed. This section shows me how many power cuts I had today. Then this one shows me how much power I'm consuming on the main circuit, and this one shows me how much power I'm consuming on the inverter circuit. So this includes all of this value as well. So the 17 or 2000 watts here includes the 1400 watts on the inverter side as well. This here shows the capacity of the inverter and how much runtime I have based on this load. So as you see, the load went down, then the runtime increased. This helps me judge how much runtime I'll get from my inverter, and I can turn off devices if I need more runtime. This took me a while to set up, but I'll show you all the detailed configuration in a GitHub repository that I've made. For my automations, I'll attach some screenshots as well, but I'll show you my automations section as well. So let's see. Okay, so here are all my power related automations. So one of the most frequent ones that I use is this one. So this one sends me a inverter power loss. This basically calibrates how much power consumption was there when the power loss happened, and when the power is restored, it calculates the power that I utilized during the power cut, and then I get a message on my Telegram telling me how much power I used during the power cut. Let's see, inverter power restored. Yes. So here's the Telegram bot message that I get. Inverter power restored and inverter delivered this much watt hours during this round. I'll attach a screenshot of a Telegram message as well. What else is there? When the mains power is restored, I get another message which tells me how long the power cut lasted. I could have combined these two automations, but I've made them separate because this one, the inverter power restored, can be triggered if the generator is turned on as well. So that's why these two are separate. But in case you don't have a generator, you can combine these two because these two are essentially the same thing. When the mains power is restored, the inverter power will be restored as well, unless you have a generator or some other source of mains power. What else is important? All the others are rarely triggered. So for example, this one, low battery, is triggered in case the inverter battery goes below a threshold. I manage all those variables from this config section here, where I can set the threshold, set if I get an alarm or not, and all of the other things. That is all for the Home Assistant side. I'll try and attach some screenshots of the messages that I get on Telegram. Other than that, this is all there is in this video. If you have any comments or if you think I missed anything in my GitHub repository, please comment down and I'll try to address that. Thank you.